Thank you. Thank you for staying here. Thanks for the organizer and the chairman to allow me to add this presentation today, and have a family emergency and I have to leave early. Just want to have a chance to review with you the US standard for wood structures and for design and construction. To show you a few examples of the wood structures we built in the recent years, this is a Cathedral of Light in California. It's a church. It's a glulam structure with a glass exterior supported by the glulam structure inside. Chicago Bear football practice facility is a football in US is American football. They throw the ball with the hand, not kick the ball with light soccer. A large reservoir cover in California, 650,000 square foot, is Alaskan yellow cedar, a naturally durable species. Part of the columns are submerged in the water, and that's why durable species were chosen as the material of choice. We also use wood for office buildings. A lot of glulam here and in Portland, Oregon. In the Microsoft campus, they have some building built with wood. That's in Redmond, Washington. Airport terminal, this is in North Carolina. The ice arena in Anaheim, California, where Disneyland is, and this is for ice sport activities. Highway bridges built with wood construction. Chemical storage facility in Portland, Oregon. You can see the glulam structure used in here, and wood has a special feature different than other building material is they are very good in resisting chemical attack or chemical corrosion. This is the first we call a CLT building in US built last year. CLT is talked about by a lot of engineers in being a new product, even though it's used in Europe before for about 20 years, and this is the first in the US we built in with a CLT, cross-laminated timber. We built a lot of mid-rise construction, 4 or 5-story building. One story concrete on the bottom and four story on the top. This is just apartments, dormitories, residential units. In the last 30 years or so, we built an average of 1.5 million housing units a year. And wood is 90% of the residential construction use. It's the largest wood consumption part of the consumption, 90% of all the residential construction, there's very high percentage of the wood goes in there, about 60% or more. With wood frame, we can have a lot of material available to do that. Solar sawn lumber, we apply wood for sheeting or OSB or end-strand board, wood I-joists, and glulam. Talk a little bit about, the U.S. It's a big country. We have northern states with very cold temperature, snow for several months of a year, 3 or 10 foot high. And we also have a lot of wind hazard. Hurricanes, tornadoes, and this is a map of the hazard map of a probability of a severe wind damage, in those areas. The darker brown area is sometimes referred to as the Tornado Valley. There's tornadoes oftentimes, during some seasons, and severe damage. One type of damage with the wind is the uplift. They will just lift up the roof, and the roof is gone. This is a picture from 2003. That's more of the east side of the country, but on the west side, along the Pacific Ocean, we have earthquake hazard. You can see that most severe earthquake hazard, the brown and red-brown area, on the west coast of the U.S. This is a damaged building in 1994 Northridge earthquake. It was 3-story. Now you're seeing only 2 because the bottom story collapsed. And in the U.S., American Wood Council is the voice representing the industry in developing building code and standard for wood design and construction. And I work with them on this presentation to share with you about the U.S. system of codes and standard. American Wood Council, AWC, with several engineers and conduct research with universities and writes the design and construction specification for use in the regulatory area and building code. In the U.S., the building code and the regulation is not written by government. This is very different from other countries. And the professional groups, like the building code, is written by the building officials from different jurisdictions, city, state, and county, not by the government again, And the people might be working for the government, but they're not representing the government to be there. They're working on writing standards to represent their expertise and interests. Other groups are ASTM International, standard do a lot of testing, material specifications, ASHRAE, for energy, and NFPA for fire protection, ASCE, the low standard developed by them is American Society of Civil Engineers. The Building Seismic Safety Council are the people that write the P standard document for seismic design. That, of course, include all materials. And the building code itself, we call it International Building Code, the latest edition, 2012. They are updated every 3 years, and is used by 20,000 jurisdictions, as state, county, and city governments. The building code is called Model Building Code. That means they write the building code until the state adopts it. It's not a legal document, it's just a model. When the state adopts it, they can put amendment to it. That's to fit their local usage, sometimes political. They can regulate buildings and say you cannot build so high for so much for other reasons. There's other material interests, the steel, concrete, masonry, brick, metal, and other proprietary products. And these groups, we work with them because some of the buildings are built with concrete, steel, and wood in combination. And sometimes we compete with them because the steel structure wants to take over the market of wood structure and things like that. American Wood Council developed standards for wood design and construction. That includes the National Design Specification for Engineering Wood Design, a wood frame construction manual, and the special design provision for wind and seismic design, and the permanent wood foundation. The National Design Specification, NDS, include design of all wood materials, some pole and pile, lumber, glulam, engineered wood, coarse-laminated timber was just added 2 years ago. And these standards are certified or developed under the consensus process overseen by ANSI, American National Standard Institute. They make sure the balance in those committees writing those standards are represented. 1/3 producer, 1/3 user, 1/3 of general interest. Then you have a mixture of academics, professionals, and the material producing people that has expert on the material, and then all these interests mixed together, and they all have voting rights. Inside the standard, in this engineering design standards, are various specifications, knowledge we learn from research, from monitoring. For example, the wind will be described as the uplift, pressure on the side, leeward, forward, things like that. And wood structure tend to be fail if they do, in several ways, by uplift, both wind and seismic, a base shear by shaking it, either the wind push it or the earth shaking, or whacking. If the foundation is strong enough, the structure itself will move. The overturning, and these are the things that the structural engineer designed, and it's all addressed in the standard. Well, for the non-engineers, they will be seeing those graphs and the formulas to be blah, 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 blah. You will see a lot of things in the standard to be describing the load path, how the load, either from the wind, from earthquake, or from people in the building, creating onto the structure, which needs to be safely transmit onto the foundation and to be safe. And you see a lot of movement, how to describe, how to check it. You cannot have too much movement in a building because it won't be safe, to be that. Formula describing how to determine deflection or movement of structures. Those are the type of things the engineers, myself included, will go to workshops 8 hours a day just to be seeing all these things of different type, through and learn how to properly use them to design. I won't give you all of those details in here. But all those information are from research. Means research generates knowledge, and the knowledge turns into design specification. Then we can design accordingly to produce safe structures. Connections get tested, material get tested. That's how we generate structure. Other than structural design, fire is also a concern with all materials, wood included. Systems with fire protection, like in light frame wood construction, gypsum wallboard is used to provide the fire protection to achieve 1 hour, 2 hour, 3 hour of fire endurance. And relatively, compare wood to steel. For the similar size beam, you can see the glulam beam, the steel beam about same size, which is, this beam tested is 7 by 21, 7 inch by 21 inch. In about half an hour, the steel beam have collapsed, but the glulam beam only charted by about 3/4 of an inch, and still structurally sound. And wood is an insulator for both energy and for fire. On fire side, when the wood gets heat, above 250 degrees or so, it gets burned about 400. They will chart. When the charting develop, the chart itself, it actually insulates more of the heat and the fire from going down further. We also do a blast resistance testing of different structural construction details. You can see before and after one blast test. In earthquake design, there's a lot of development. The standard changes every 3 years to get more new research information into it. And we sometimes talk about, maybe in an earthquake situation, staying at home if you live in a wood construction are safer than you are on the street or outside in other buildings. About 5 years ago, one of these 6-story wood frame building was tested in Japan as a US funded testing, and after severe shaking by the history of similar to other earthquake, the structure were performed very well. It's well documented. You can go to YouTube to see video how the testing goes and the subsequent survey of the damage, if any, which was very little. This, I think it's niche wood project. If you go to YouTube, you say NESS wood. You'll find a lot of testing there. Green building standard is another sort of standard which is around 10 years now. It's very popular. Almost the design now is trying to achieve the LEED criteria, gold, platinum, or silver, and LEED stands for Leadership in Energy and Environmental Design. They promote energy conservation, a lot of reduce waste, use local material, that type of criteria. For the design professional, architects. And currently the LEED standard is version 4. Every few years they will update their standard with their committees. There's other green building standard, both from ICC on the International Green Construction Code, as well as the committee in ASTM on sustainability, and I share that regarding energy requirements. In various states, they also can write their own green building code or adopt the IGCC. The idea of sustainability design is based on life cycle assessments, cradle to grave, tracking the energy use and material extraction all the way through from extraction, manufacturing, shipping, packaging to the end use and disposal. We know that, talking to all of you, is wood, is the only renewable material available. And in a typical American house, it's about 2,400 square foot, single family detached. It contains about 29 metric tons of carbon dioxide. By building one house, it would be equivalent storing carbon for 5.7 passenger vehicles annual emission. We will say that by building more wood houses, you clean up the air. As more information, the society is in demand of more information about environmental benefits of using wood, and the industry is developing environmental product declaration. That's for various products from softwood lumber, plywood, OSB, and that is set up the criteria to be able to establish some sort of a label. This is actually a nutrition label for food items, but this is not yet done. We expect to be able to produce a label this type in the future, in the next few years, that accounting for the benefit of environmental benefit using wood. It will be either carbon storage or reduce of CO2, carbon dioxide, and the scientists and the researchers will be doing that. There is other material that is mixed together to build houses. This is a structural insulated panel with OSB on the outside with foam in the inside. Forms a panel that houses can be built based on those type of systems. Provide very good energy efficiency. We know that now we can build wood structure with various shapes and from various uses. We can also build very, very long span wood members. And oftentimes, how long the member can be built with Gulam or LVL, that type of engineered wood product, the limit is probably on how you can transport it. They can build as long as you want if you can have a way to transport them to the location where the building is. This is a 140-foot long clear span Gulam beam. With wood, you can do a lot of unique connections, a lot lot of people like to use wood because the natural aesthetics. We're looking forward to the future to build more. The future engineer would be looking at, this is a study by the SOM firm in the US. They have redesigned one of their structure, which is 42-story in Chicago. They put it together with a new design. They think they can go to 42 square with primarily a mass timber structure with using concrete and steel components to put together. The total finished project will reduce carbon footprint compared to the old building they built 30 years ago, would be reduced by 60 to 75%. That's the advantage of using timber or wood for construction.